Hello, this is Ms. DB, and in this video I'm going to review how to do some of the problems from Chapter 3, Section 3. So you should have already read pages 162 to 165 in your textbook to get a good overview. You should take notes, write down any definitions, postulates, and theorems that are in this section. Our objective is to use the angles formed by a transversal to prove that two lines are parallel. So in 3.2, Chapter 3, Section 2, we are given that lines were parallel and then asked to say whether or not angles were congruent or equal to 180, which is supplementary. In this section, we're going to be given some facts about the angles and then asked to prove that the lines themselves are parallel. So to do that, we use a converse of a postulate that we used in 3.2. We are going to use the converse of the corresponding angles postulate. This says that if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. And again, look back at the longer video or read the book to get more information on this. Here's an example of how you would use it. You're going to have to write some stuff to explain in these problems. So here we are given that angle 1 is congruent to, I have to get my drawing tools here. We are given that angle 1 is congruent to angle 5, so we find those, and then we look at what kind of angles those are. And angle 1 is up here, and angle 5 is here. These are corresponding angles. So because they're corresponding angles and they're congruent, we can use this postulate that we just learned, which says that the converse of the corresponding angles postulate says that if you have congruent angles and they're corresponding angles, then you know that line M is parallel to line N. So you just would have to write that then because of the converse of corresponding angles postulate, these are parallel lines. L would be parallel to M. Now this one's more work. They give us that the measure of angle 4 is equal to 2x plus 10, and that the measure of angle 8 is 3x minus 55. And they also tell us that x equals 65. So we're going to find what the measure of angle 4 equals by plugging in 65, and we get 140. And then we plug in 65 to the second expression, and we get also 140. So these are also corresponding angles, 8 and 4. They're corresponding to each other. So because they're corresponding angles and their measures are equal, then we can go ahead and say that by the converse of the corresponding angles postulate, then these are parallel lines. So let's move on and look at your problems from your worksheet. First, we find for number 1, we're going to find 4 and 5. Angle 4 is over here, angle 5 is here. Are these corresponding angles? And they are. So you would, for the explanation to show that P is parallel to Q, you would write, angle 4 and angle 5 are corresponding angles, and given that they are congruent. So by the converse of the corresponding angles postulate, P is parallel to Q. All right, let's look at number 2. Number 2, I'm going to get a little bit more space here for myself. So for number 2, it's got some information there. First, we look at angle 1 and angle 8. 1 is over here, 8 is here. So I would start with angle 1 and angle 8 are corresponding angles. I'll just abbreviate that to corresponding angles. Second thing, I would use x into each expression, substitute it into here and here, and see what I get. So measure of angle 1 is going to equal 4 times 28 plus 16, and see what you get. And then measure of angle 8 is going to equal something, and see what you get. If those two measures are equal, then you can say that their measures are equal, if that's what you get. It's really the transitive property, but you don't have to write that. You can just say that they're equal. So if you have corresponding angles that also have equal measures, then you can use the converse of the corresponding angles postulate to say that the lines are parallel. So you would write converse of the corresponding angles postulate and say they're parallel. And then you could also call this by the, what was this one called? You could say by postulate 331 to save yourself a little writing. So by 3 point, or was it dashes? And then you could say P is parallel to Q. And then the last one you'll do the same way. You'll see if angle 4, let's find angle 4 and 5 up there. If angles 4 and 5, here's 4 again, and here's, we already said that those are corresponding. So you would write that because angle 4 and angle 5 are corresponding, and then you would plug in 11 and see if you get the same measures, and you do the exact same thing. Okay, here's another one. This says that the parallel postulate says through a point P not on line L, there's exactly one line parallel to line L. So if you have a line L and a point not on it, there's exactly one line parallel to line L. There's only one way to draw a line through P, and that will be parallel to L. Any other line you draw would not be parallel to L. This is only true for the kind of geometry we were doing. If you're talking about 3D space, it actually changes, but we're just working with Euclidean geometry, so we'll stick with that. Okay, so here are some more theorems that go with this chapter. These are important. Remember that these are the converses. Each of them is the converse of one that you learned about in 3.2. So go back and review the alternate interior, the alternate exteriors, the same side if you need to. Okay, so the converse of the alternate interior angles theorem says that if two coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the two lines are parallel. So again, in these converses of the theorems, you're starting with a statement about the angles themselves, and then from that you can say whether or not the lines are parallel. And then the converse of the alternate exterior angles says that if you have congruent exterior angles, then you have parallel lines. And the same side interior angle one converse is different. This one says if two coplanar lines are cut by a transversal so that the same side interior angles are supplementary, which means the sum of their measures equals 180, then the two lines are parallel. Here's a proof of the converse of the alternate exterior angles theorem. It says that vertical angles are congruent. We're given that angle 1 is congruent to angle 2. We can use vertical angles are congruent, and then we can use the transitive property. And then we can use the converse of the corresponding angles postulate to say that then we know that angle or L is congruent, is parallel to M, which is what we're trying to prove, that the lines are parallel. Okay, so for number 4, this is basically the answers. It tells you what to do. But you're going to take what's written here and put it into a 2-column proof. All right, so here we have the statements, here we have the reasons. Some of them are there, some of them are not. So our first statement is that angle 2 is congruent to angle 3. Well, that's given. So you write given. Then the next one, it says angle 1 is congruent to what? And you can look at the flowchart proof to see what that's going to be. But angle 1 is congruent to angle, oh no, it's not there, it's missing. That's going to be this though. Angle 1 is congruent to angle 2 by vertical angles. So that's going to go here. Then angle 1 is congruent to angle 3 because right here and right here. So we'll have angle 2 congruent to 3. We'll have angle 1 congruent to 2. So if 2 is congruent to 3 and angle 2 is also congruent to 1, then you can put these together using the transitive property. And if you can put these together using the transitive property, then you have just said that angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. This is their corresponding angles. So by the converse of the corresponding angles postulate, you can say that the two lines are parallel. So this word you have to fill in, corresponding. All right, let's look here. We have that angle 2 is congruent to angle 6. And if angle 2 is congruent to angle 6, then we can look at what kind of angles these are. Well, these are alternate interior angles. So if they are congruent, then by the converse of the alternate interior angles theorem, then I know that the two lines must be parallel. And for this one, if you find angle 6 and angle 7, let's see, angle 6 is here, angle 7 is here. These are same side interior angles. So their sum, they should be supplementary. The sum of their measures should be 180. So I plug my value of x in for both of them, and I see what I get. I got 78 and I got 102. If you can add those together and get 180, then by the converse of the same side interior angles theorem, I have just shown that the lines must be parallel because the sum of those two is equal to 180. So you will, again, they're almost like mini proofs. You don't have to write a 2-column, but you do have to explain what you're doing for each of these. Okay, so I'm going to, again, move this down a little bit so that my picture is with my problems. On this next section, you're going to do the same thing. You're going to look at what kind of angles you have, and then use one of these converse theorems or postulates to say how you can show that the lines are parallel. And there may be some that you cannot tell whether or not the lines are parallel. There may be some that you don't have enough information to say that. So let's look at angle 7 and angle 3. Angle 7 is here, angle 3 is here. What kind of angles are these? Look back at section 1 in this chapter if you don't know by now what kind of angles these are. These are alternate interior angles. It tells us that angle 7 is congruent to angle 3. So by the converse of the alternate interior angles theorem, this is the theorem, they're all theorems except for the corresponding one, M is parallel to N. Okay, let's look at number 7. In number 7, we have that angle 7 is congruent to angle 6. What kind of angles are these? These are same side interior. But same side interior angles are supplementary. They're equal to 180 degrees. So them telling us that they're not telling us they're supplementary. They're saying that they're equal to each other. So they're supposed to be supplementary in order to be able to use the converse of the same side interior angles theorem. So we cannot tell from what the information they give us, we cannot tell if M is parallel to N. There's not enough information. The theorem is that they need to be supplementary, and they didn't tell us that. So that one's one that doesn't have enough information. How about, let's look at one of these that has more stuff. Number 12 is one that a lot of people get confused with. We have measure of angle 6 is x plus 10. Measure of angle 2 is x plus 15. So these are alternate interior angles, but they did not tell us if they are congruent to each other. Let's see if we can figure out anything from this. If we have x plus 10, if they were equal to each other, then their measures would be equal. But how could I possibly, I'd have to subtract x from both sides. I'd get 10 is equal to 15, which is not true. So they must not be equal to each other. So we have measure of angle 6 is not equal to measure of angle 2, because when we try to set them equal to each other, we got a false statement. So these lines are not parallel. At least not by the information that we are given there. The second thing, this is just the same problems, but it's just I just copied and pasted it, because sometimes when people open this in Word, like all the angles might disappear to little symbols, or the congruent signs might look weird. So, and then the last one is just completing a proof of this. Here we've got angle 1, mark these, is congruent to angle 2, and we've got that angle 3 is congruent to angle 1. And we are supposed to prove that XY, this line, is parallel to this line. So we write down our given information. You're going to complete this table. Some of it's up there. And then we are given, the next step says that 2 is congruent to 3. Is that part of our given? Nope, it's not part of our given. So then you need to look at what we wrote in our first statement and see, is there a way to put this together using a property that we keep using to go here. So it's, if we know that angle 1 is congruent to 2 and angle 1 is also congruent to angle 3, then we can put these two parts together and say they're congruent. So you should know what property that is. We've been using it since chapter 2. It starts with a T, TR. Okay, and then from there we have that angle 2 is congruent to angle 3. Okay, so if angle 2 is congruent to angle 3, what kind of angles are these? Here's your lines that you're trying to prove parallel, and you've got these two. So here's your transversal. So you need to figure out, are these corresponding? Are they alternate interior? Are they alternate exterior? Or are they same side interior? Once you figure out what kind of angles they are, then you use the converse of that, the converse of the blank angles theorem to fill in a blank. And this, of course, will be what we're trying to prove, that the two lines are parallel to each other. So the only thing you need to figure out is how are angle 2, what kind of pair of angles are angle 2 and angle 3. All right, this video got a little bit long. Sorry about that. I'll try to speed it up next time. Thanks a lot and have a great day.